Yep. Am I on? Can we hear me? Yep. Okay, I can hear me. Cool. Hi, PyCon. How's it going? Woo! Nice. Okay. So I'm here to talk about an open source artificial pancreas, and it looks like this. Here's mine. All right. Thank you very much. Um, I'm, I'm, I'm kidding. I'm kidding. So if you're like most of the people that hear about this, or new friends that find out I have one of these, you probably have like all of a sudden 50 new questions you want to ask. So I'm hoping to kind of start to cover a lot of those in my little spot here. But first, little introduction. My name is Sarah Withee. I'm a software engineer. I like calling myself a polyglot software engineer, so I don't really stick with one particular language. So I work in Python and a whole bunch of other languages I won't bring up here. I'm also a robot and hardware tinkerer, so I like playing with different IoT things and things like that. I also do a lot of public speaking, teaching workshops and things like that. I'm also a type 1 diabetic, which I haven't used to share. I didn't used to share that much. I've started doing it since I think this technology is really cool. But in the process of sharing a lot of the stuff, I've been able to start to meet other people that are type 1 diabetics or family members, friends of other diabetics. And so they've been interested in this technology as well. So I've been really happy to kind of share that part of my life. But to really explain kind of what this device does and how it works, I kind of need to backtrack a little bit to the science of kind of what goes on. So the quick rundown of carbohydrates, which I'm sure you've heard of, is that when you eat a bunch of carbohydrates, and sugar really is kind of a form of carbohydrate, your body breaks those down into glucose and fructose. For this talk, we don't care about fructose. The glucose then goes into your bloodstream. Your pancreas sees that rise in glucose and says, like, oh no, I need to do something. So it makes a hormone called insulin, which you probably also heard of. Your body's cells see that insulin and then start to use that along with the glucose and use that to make energy, or use it for energy. So you can kind of see that carbohydrates are a really sort of important nutrient that your body needs. And diabetes is kind of where this whole process doesn't work right anymore. You probably heard of the different types, but just to kind of go over them. Type 1 is an autoimmune disease, so something in your body has attacked those cells that are making the insulin, so you don't end up making any more. Type 2 is where your body becomes resistant to that insulin, so you're still making it, but your cells, for some reason, aren't using it all up correctly. And then there's gestational, which is where once you become pregnant, your body then becomes resistant to it, which is sometimes just temporarily while you're pregnant and sometimes kind of permanently. There's a few other rare types too. I landed in the hospital once where I had a swollen thing in my stomach and they needed to do surgery and they did a blood test and coincidentally I was diabetic. They're just like, surprise, you need surgery and now you have this lovely chronic disease. So, but they found out later I don't have the autoimmune disease, but I'm still type 1, which is sort of a weird thing, but not really important for the purpose of this talk. Some more rundown. In the United States, we measure this, the glucose in your blood, using milligrams per deciliter. And a deciliter is like 1/10 of a liter. So sort of an odd amount, but it works. Other countries use millimoles per liter. And there's like a conversion rate for that, but for the purpose of this talk, we're not going to go into that. Before meals, normal people, or as I like to call them, civilians, usually are about 70 to 100 milligrams per deciliter. And once you eat, obviously, the more glucose enters your body, so it kind of goes up for a little bit and then goes back down. So somewhere in like the 70 to 140 range. For diabetics, you usually have to manually do this process yourself. So doctors like to give you a wider range. So usually 80 to 150 and then 80 to 180 for those two ranges. And that's just because we'll find out in a little bit, you don't want to go too high and you don't want to go too low with that. So the problem is that diabetes is really hard to manage. For one thing, normal people usually aren't told about the warning signs until it's too late. So I know when they found it in me, they're just like, well, these are the warning signs. Didn't you see those? And I'm like, well, yeah, I saw them, but I thought I had excuses for all of them. Like other things were going on that led to these. The other case was that usually diabetics are told either too little information or too much information. So there's sort of this overload. And sometimes they're usually really terrible at math, so you'll start to find out there's a lot of things that we have to kind of take account when we deal with all this. So another reason it's hard is we have to start counting how many carbs we eat and how much medicine we have to take for it. It's not just a simple, you always take this amount 3 times a day. We really have to do it based on what we eat. So a unit of insulin is 1/100th of a milliliter. So just throughout the course of this talk, we'll just talk about units. And this carb ratio is, so however many number of carbs you eat, that amount of insulin is what you need to sort of counteract that in your body. These ratios can be anywhere from usually like 3 grams to 50 grams. So this ratio is really, really wide. And we'll also find out that this ratio varies from person to person. So if you look at the people around you, their carb ratios are different than yours. It can vary at different times of day. So I know I need a little bit more insulin at the beginning of the day, and in the evening I usually need a lot less, or a little bit less at least. And then under different conditions. So when you're sleeping, you might need a little less or a little more, kind of depends. When you're stressed, we'll find out in a little bit that ends up making things go up. Different things like that can alter this ratio. And then it changes over your lifespan. So your ratio last year is not the same as this year, which is not the same as next year. Kind of a pain. To add more interesting complications to it, when you start to eat your carbs, within 10 to 20 minutes is when those start getting into your bloodstream. But the insulin that you would take to counteract that starts kind of slowly at first, and then hits really hard about 45 to 60 minutes in, and then just over the course of 5 hours, finishes absorbing. So there's this really weird curve. But this, where the blue line is the absorption rate for insulin. So it kind of picks up in about the course of an hour and then tapers off over 5. And the purple area is your reduction rate of that glucose in your bloodstream. So it kind of starts going down slowly, dives down really fast. Let's make it more complicated. So if your glucose gets too high in your bloodstream, bad things start to happen. So it ends up clogging your capillaries, the really, really fine blood vessels in your body, which is why people end up with circulation problems in your feet. They lose their eyesight, sometimes their kidneys go bad. These are all places where that glucose can build up and stop your prevention. And then organs slowly die. I hate to kind of say that, it's kind of bad, but yeah. When your glucose goes too low, you end up with sort of a different type of problem, where immediately you start shaking, you start sweating, you get really weak. I get sort of like foggy brained, where I'm like, I'm there, but sort of weird things kind of happen. I pretty much have to set, and I'm like out for at least 20 minutes. Worst case scenarios, you can land in comas in the hospital. It's really not great. You don't want that to happen. So we have to maintain this like perfect level on top of like all these ratios and things we have to figure out. So let's make it more complicated. When we're stressed, our body makes our glucose levels rise up, and same for when we're sick. It kind of goes up as well. When we exercise, it goes down because your cells need more energy, so it can use up what's in the bloodstream. If you have a little bit to drink, most alcoholic drinks usually have some carbs in them, so your sugars are going to go up. But if you drink too much, then your blood composition's a little different, so your glucose ends up going down. And then if you happen to have, that special time of the month, your glucose can also go up. So, a lot more fun adventures in diabetic land. But I'm not done. Correction ratios are what happens when you go high, and you need to take some medicine to make that go lower. So however many milligrams per deciliter high you are, there's a ratio of, you can bring that down with so many units of insulin as well. Similarly, this also varies from person to person. It can vary over time, all those different things too. So hopefully you're completely overwhelmed at how insanely complicated all of this is to do on your own. But hopefully as technologists in the room, you've been kind of thinking like, wait a minute, can't we use technology to fix this? You're right, we can use technology to fix this. So there's 2 main things that have been around for a really long time that diabetics use. One is called a continuous glucose monitor, and one is an insulin pump. And you may have seen these. The first one's called a continuous glucose monitor, or CGM. I have one on my arm right here, this little lovely pod thing, whatever you want to call it. So every 5 to 15 minutes, they can grab a measure of the glucose in my blood, and then over Bluetooth, send it to my phone. which right now it's not actually sending to my phone, but so I can get a live value at any moment of what the blood sugar in my body is. And so you can kind of see in the picture, there's this tiny little needle that just goes under the skin. And it's kind of like hair, like it's really flexible. It's not even really like a needle, it just kind of sits in there. So as I kind of move my arm, that whole thing can move with it, so it's not even really uncomfortable. I don't even feel it going in. The other part that you've probably seen people have is called an insulin pump. So it attaches with a tube to your body. There's no good place in a dress to keep this, so there you go. This is mine right here. So mine's attached to my stomach at the moment. But basically, throughout the course of a day, it delivers insulin to my body. And I can go in and punch in there, like, give me 2.5 units right now. So it would do that. So it's kind of nice that I can go in and say it whatever I want it to do. And there's also, your liver makes glucose all day, so it has a built-in value to kind of give me a little bit throughout the course of the day, too. So that's kind of nice, but it's a really static process. This doesn't do anything on its own. It's really kind of stupid. So, and the other problem is they don't talk to each other. These two things kind of live independently, but they don't interact in any way whatsoever, which is kind of where this do-it-yourself artificial pancreas comes in. Moving forward to the 21st century. All right, so that's where this little doodad comes in. So there's two main types that are kind of out there at the moment. One's called OpenAPS, which is the Open Artificial Pancreas System. And it's a Linux-based IoT device. So I have a little thing on here. It's running Debian at the moment. It's attached to a 900 megahertz transceiver. So it can send out signals and listen to the airwaves. And all the code, including the board it's on, is all open source. We can go to GitHub and get all of that stuff. So it's kind of cool. The other main one is called LoopKit. So it's the open looping framework, where looping is sort of this process of using the values on the blood sugar meter and changing the insulin pump values from it. So it's also similarly, there's another Bluetooth transceiver board. It runs on its own, so it doesn't do the calculations like this one does. Your phone does that. So your phone tells it to tell your insulin pump what to do. And all that's open source as well, but it's really geared just towards iOS devices, whereas OpenAPS can be used for either one. So this is where the looping process comes in. So your CGM gets the value of the bloodstream, sends it over Bluetooth to a receiving device, which I use my phone, and I use this open source app called Xtrip, which I really like. This app then sends it up to a database, basically, and one's called Night Scout that I'm using. And Night Scout will collect all these values, but also kind of collect the trends in device statuses. Since I don't know, like, the battery value of my thing, it collects that as well. And these you can deploy to a free instance of Heroku or Azure, which is kind of nice. From there, one of your devices, either the LoopKit or the OpenAPS, will download those values, look at kind of the trends that are happening over 15 minutes, 4 hours, and 24 hours, I think. Kind of figure out what's going on with your body at the moment, kind of what your sensitivity is, and then take that and send some information to your insulin pump to say, either give you a little more or give you a little less medicine. So it's pretty cool. Time for a live demo. So really quickly, I'm gonna back out of this. Gonna mirror my display. Cool. All right, so the live demo pending the internet working. Cool. Besides the big red mark there. For whatever reason, it hasn't gotten a value from my CGM for 34 minutes, but that's fine. Last it read, it was 102, which anybody remember if that was good or bad? Pretty good? Yeah, it's fine. So these little plot points here are individual data points. I don't know if you can see my mouse cursor at all, but the green dots are individual data points. The blue dots are kind of its trends. So given one particular algorithm, it thinks like it could possibly go up a bit. One algorithm, it says it can go down a little bit. And it's not doing very good predictions at the moment because it hasn't gotten a value for a few minutes. I'm guessing just signal interference in here. But I can also turn on basals. And the basals is like that all-day value. we can kind of see up here in this blue bar. So there's a dotted line. It's going to be really hard to see on the screen. That's the default value that's programmed in the pump. And those blue lines are it adjusting my insulin throughout the course of the day. So there's a couple times where it's just like, I'm going to give you a lot more to try and keep that level. But other times where it's just like, hey, you're doing fine, let's dive that down a bit. So you can kind of see over the course of 12 hours, it's made a pretty good amount of adjustments. And the great thing is this works overnight as well. So I don't even have to be awake to let this kind of manage things on its own, which is really good because a lot of diabetics struggle with what happens if it goes low in the middle of the night and they don't wake up. Really bad things can happen. So systems like this can help prevent health issues like that. If I can plug it in real quick, we can show you kind of live on the device itself. All right, so cool. I'm still logged in. Sarborg is the name of my device. Sarah, Cyborg, Sarborg. I was hoping some people would be amused at that. If I can run this log command, so it can see live at any given moment what it's doing. So it looks like kind of at the bottom here, it's just started our loop process. Since you can only get a new value every 5 minutes, it doesn't like constantly calculate. So it really only makes sense to like every 5 minutes do some of this data analysis. So it waits a little bit. But you can kind of see there's a whole bunch of log data up there. So what it does is it listens for some radio interference. If it gets the all clear, it then starts talking to the pump, finds out the latest dosages maybe the pump has given out, sync that with its own data up in that Heroku instance, the database app, and then kind of see what my trends are, and then send a new value that says, hey, insulin pump, for the next 30 minutes, give this much insulin instead. So it's constantly giving like all these little minor variations, which in turn ends up in that little kind of graph. While it's doing that, maybe we can go back to, we don't want to start at the beginning. Of course, it's on the wrong monitor. Get that back over here. Slideshows, am I right? All right. So hopefully that was kind of cool. Let's go to the FAQ section, which, like I said, a lot of people usually ask me a lot of interesting questions about this. So usually I first get, wait a minute, is that really a pancreas if it's not like actually inside of you? And I guess no, it's not actually like a legit pancreas, but it really much replicates all the things that your pancreas does anyway. So kind of artificial pancreas is like the simplistic way to call it. The more technical term would be like an open hybrid looping system, which nobody knows what that means anyway. So, okay, so if this thing is on the internet and it's giving you medicine, like, is it really safe? And the answer is yes, it's actually pretty darn safe. The woman that discovered the initial algorithm to kind of do this pretty accurately, she is a researcher and was doing this against her own blood sugars. Ended up getting like some values from other people, testing her algorithm against those, seeing if, you know, it was responding correctly. And then her husband was a software engineer, wrote some of those into some scripts, and then some other people found how to wirelessly communicate to the pump. And then sort of all these like little small scripts came together into sort of this bigger package. Everything is published online, including both her research in researchy format, as well as kind of, you know, you can see everything on GitHub, you can understand sort of the process of the algorithms. And also there's hard limits. So I said in there, you know, you cannot give me more than so much insulin at any given hour. So it will never go above that. And if it tries to, it sort of shuts off the whole system. Okay, and again, kind of if it's online, can't you hack it? I'm like, sure, anything online can be hackable. But let me tell you how you would actually have to hack this. So first you would have to find the IP address of my phone. And second of all, you'd have to find the IP address of the device that's tethered to my phone. And then once you find that, you actually have to log on to the device through Linux. And then once you do that, you then have to find the script that actually issues the commands to my pump. Wait several minutes for that communication process to happen. And then once it starts dosing, It's really slow. Remember how I said it takes the time? Because otherwise you just get this big buildup of insulin in you. So then it's really slow. And then because it takes so long to absorb, I would probably detect something weird is going on with my body before anything bad happens. And I would just eat a bunch of like candy or something to make it go back up. So it's great. Whenever I go low, I'm just like, yes, I'm eating cookies for my health. As I like to call like the day after holidays with a bunch of candy, hypoglycemic discount day. Anyway. So yeah, you can hack it, but I think the process is in no way like worth the effort to actually do this. You would have to really, really, really not like me, and then at its worst, it's really like just a bad inconvenience. Is it kind of annoying to carry all this stuff around? Sure, I mean, like, I have to either carry it on my backpack or attach it to like a purse or a belt loop or something like that, so it's a little bit annoying. Because I've been gone for a few days at a conference, these are all like my spare insulin pump supplies, extra insulin, CGM things, a whole bunch of nonsense. So that's a little bit annoying, but my health is so much better because of this. It's managing a lot of things I don't have to do anymore, which is really great. What if the battery dies? Good question. So yes, I have to charge my pancreas. It happens. So if it dies, then the pump just doesn't hear anything anymore. That temporary value quits, and then it goes back to its default. So it goes from basically dynamic back to static. It doesn't like kill me or anything like that. Same for if it loses internet access. Since it can't get those values and can't really detect the trends, it just kind of goes back to that default status, which is sort of what's happening now because it can't read the things on my blood sugar meter. Why is this not FDA approved? Complicated question, but the simple answer is it's not a sold product. So you don't go to the store and buy this. It's kind of this hacked together Internet of Things device that I'm using to sort of, mess with my body. So since it's sort of like a home-built device that only works on me, it doesn't really have to go through the FDA. And why have not any of these medical technology companies really jumped on this yet? And the simple answer is they usually claim it's too expensive, too risky, too whatever, their tech that they're already using works, people are paying gobs and gobs of money for it, so why change anything? But as they're starting to notice this open source community building these things and it's working really, really well, and it's getting a lot more publicity now, they've started to think like, okay, so I guess we need to release some technology like this. And one company has released sort of a looping system. It's not really great. People keep complaining about how kind of terrible it is. But an organization called Tidepool, which does some data analytics on blood sugar values, has jumped in to say, you know what, we'll be that intermediary. We'll let you keep your proprietary technology, but we want to help enable open source software like this, be able to talk to your pump. So I think only within like the last week or two have they actually released a beta version for the first company that they've been talking to. So it's really been kind of fascinating to watch this process just blossom only in the last couple months. Kind of to start to end it up, the top one is kind of an example of perhaps a typical day without the pancreas going. So you can kind of see I have a lot of high values there. On good days, maybe it roller coasters a bit between good and bad. On bad days, it just kind of stays high and is a lot harder to manage. The bottom one is a lot busier. There's a lot of stuff going on there. But you can kind of see that value is pretty much in that perfect range, pretty much all day long. There's a couple tiny little high points. But that blue value at the bottom, it's super active. All day long, it's adjusting me to keep it as much in that green value as possible. Okay, so where is all this code? You don't have to pay attention to this. I'll post my slides on Twitter and all those things. Instructions are on read the docs for the Open APS system, which is usually Android. You can do it on iOS too. My friend Tracy does it. Open APS, Night Scout, and Xstrip are all on GitHub. If you're doing the iOS-based system, all the instructions are there too. There's LoopKit and RileyKit. RileyKit's the hardware board that does the communication. So they've open sourced that as well, which is really cool. And I kind of want to wrap it up with thinking about open source software. There's not a lot of products that we think about that actually can legitimately change lives. I think when I think open source software, I either think like one quirky library that somebody built at one point that does like one special thing, or something like Firefox, which is this huge, monstrous open source project that has like tons of funding and stuff like that. But about 30 people or so have come together to build this product. It's working great. They've tinkered with it over 3 or 4 years. It's pretty much at the point where anybody can download it and just run with it. And good examples of who it's affecting. Young children that are diagnosed with type 1 don't have to manage their own blood sugars anymore. This thing can help work with that. Because kids just want to go out and play. They don't want to sit in the nurse's office and have to get insulin shots. Their parents can also get notifications of what's going on with their body too. Older people that can't manage the medicine as well. Low-income people can run this because it's free. Those without health insurance don't need as much fancy, complicated technology outside of pumps and CGMs. I guess I'll end it with, who do you know that can SSH into their pancreas? Me. You know one now. Hi, I'm Sarah. You can SSH into my pancreas. Anyway, thank you all for coming. I really like sharing this technology. I really like sharing how it's worked well for me. You can find me on all the social media things as Geeky Girl Sarah. You can also email if you have questions or you want to learn about deploying this for maybe a family member or friend or perhaps yourself. It's hello@sarahwithee.com. Slides for everything are up on geekygirlsarah.com/pancreas. Thank you for coming, and definitely find me in the hallways. You can come see it, you can hold it. Maybe I can pull out my laptop and you can see kind of how the Linuxy side of it works. So thank you all for coming.